record to the cloud. So I think I'm recording. So great. Yeah, so as I said, we want to install some packages really quickly. So Pandas is going to provide us a cool object within Python that are going to give us like a lot of functions that allow us to manipulate data in very easy ways. So you can think of Pandas as basically a programmatical Excel. Pandas also has what you call data frames. The way I think of them are basically just spreadsheets. Think of columns being like the relations and the rows being the observations of your data set or the data that you're trying to analyze. So then we're going to do pip install matplotlib. And this is going to help us with a lot of our plots. This is the standard package that almost everybody uses for creating static and nice looking plots with any type of data that you have. This works very nicely with Pandas. So that's what we're going to use it. Oh, sorry, I did pip2, then pip3. Then it's going to be pip3 install NumPy. This provides a lot of mathematical functions that are easily accessible and we don't have to code up by ourselves. Then we have Plotly. So Plotly is going to be our main driver in this workshop, simply because they provide very nice looking plots, similar to Matplotlib, but Plotly gives more interactive visualizations that are just better looking, in my opinion. And you'll see soon when we start. So we want a specific version. So the way you specify which version you want is equals and the number of the version. In this case, we want 5.3.1. And this package, Plotly, also comes with another dependency called dash. We don't have to worry about a lot of what dash is. We just need to download it for some reason. And then lastly, pip3 install PyCountry to provide information about different countries around the world. So that might be a little foreshadowing of what we might be doing with our data. So then simply you can just click this play button or do ship return and it will run that cell. Cool. Yep. Okay, so everything is installing, and in the meantime, how about we import it to our code? So right now we installed the dependencies. You know, every time you are going to code something in Python, it's very likely that you're going to need to bring extra libraries in. So this is what we're doing. We're downloading the libraries into our, say, disk or into our environment, so we can later go into our Python code and refer to them directly. So how do we refer to them directly within our Python code? So that's pretty simple. So we can use the import. Also, don't worry about the things on top. It's just downloading. How do we import stuff? We use the import command, and first we're going to import NumPy. And the way we do this is by import NumPy as NumPy. We're renaming the NumPy library as NP because it's just common practice, and it's better just to type 2 letters than 5. So the next one is going to be Pandas. Similar with this. We named it PD. Then matplotlib. And we're going to do matplotlib.pyplot, indicating that we want a sub library within matplotlib. And we're going to call it PLT. So basically the as operator in Python renames or creates like an alias to a predefined library or say variable. So the next one is matplotlib dates. There's a lot of dates happening in our data set. So this dates library allows us to manipulate it and extract dates very easily. Then we have Plotly, and it's from the Express library, and we say as PX. And lastly, we can do some extra stuff just to make sure things work. And a command that is very helpful is you can use the percent matplotlib inline that allows us to render um, our plots without any weird formatting. So I always like to do that. You can do that, and then we could leave it like that. So that's all you need to import. So now we downloaded our libraries to our disk, and now we importing them into our, say, Python file. In this case, is our notebook. So then we can simply do the run cell or shift return. Cool, and I have a small error, so I misspelled something. Then that should work. Nothing. Oh, and I misspelled another thing. There we go. Cool, this runs. Nice. Okay, so next. So this is a data science workshop. So in order to do data science, you have to have data, or else you'd just be doing science. So what we want to do is import our data, right? And in this case, we want some sort of COVID-19 data. And so we've looked around and try to find the most simple yet clean data set that is out there. And we don't have to do a lot of pre-processing, so we can just work out of the box. So for that, we found a couple of files from this GitHub repository from John Hopkins. And how we're going to import them is by using their GitHub repo. So I'll explain how we're going to do that. So we have a couple URLs. So here they are. And for your ease, I will just paste them into the chat. Okay, somebody already did it. Thank you, Lily. Somebody already did it, so I don't have to do that. Great. So to shortly explain what I did here, I basically created 4 variables, right? If you don't know any Python, the way you create variables is, let's say you have a variable name, say in this case is countries AGG or countries aggregated. And here we're providing a string, and this string is basically the URL to where our file lives in some sort of server in some sort of country. So we have 4 different data sets that we'll be using today. So then we can click run, and hopefully you have it pasted in your notebook. So we're able to refer to the links of our data sets in the future. So how do we load our actual data set into our computer now, right? Right now we only have a link, but how do we go to the internet and grab that data set and bring it back to our hard drive? So the way we can do that is by simply creating another variable. And this variable is going to be called cont aggregated or countries aggregated. And we're going to set it equal to a very neat object that I referred to before called the data frame. And as I said, our data frame is basically just a table. You have its columns, which is basically, say, in our case is going to be the number of people that got COVID, the people that recovered from COVID, and the number of fatalities. And so the way we do that, we can simply provide the URL to our data set, and then pandas, because we refer to it as PD, will just go and fetch that that data set. And we're using the read CSV. So basically, these files that we're going to go fetch are type of CSV, comma separated by value file. That is basically a bunch of data points. They're all separated by comma. You don't really have to worry about that, but that's the function that we are using to load up our data. So before you load up any type of data, you need to know what format is it on. Is it on Excel? Is there CSV or any other? So luckily for us, Pandas already has a pre-built function that is able to import our data set in one single line. Second, we're going to parse the dates within our data set. So what does this mean? What it means is that, sorry, what it means is that we have some sort of date in our data set, right? So basically one column in our data set contains all dates. So we want this to be understandable by pandas, basically. So the way we can do that is that, okay, we import our data set, and then we tell pandas, hey, look out for this column named date and parse all those dates depending on the format that you can understand. So parse data set is a parameter, or is an argument that we pass in with the name of our column. So pandas is able to parse our dates. Once we do that, we can do shift return, or we can run the file. Sorry, parse date. Okay, I misspelled that. Sorry, I suck at spelling. So parse dates. And then our data frame is in our disk. So let's start exploring, right? So let's see, let's just take a look briefly at what these what this data frame contains. So a handy function that allows us to do that is .head. And what .head is basically, it basically says print the first 5 rows within our data set. So to explore our data set really briefly, we have 5 different columns, right? One is date, like I said, and you can see that it's nicely parsed. You can see that the year is 2020, the month is January, and the day is the 22nd. The country is Afghanistan. The number of confirmed for that date, the number of recovered for that date, and the number of deaths for that date. So it's pretty simple. Nothing needs to be cleaned and everything is understandable. And there's no missing data. In real life, when you all go to have a data science job or machine learning, data is really messy. And a lot of the work of a data scientist is pre-processing and cleaning up the data. So the data doesn't contain any errors, such as, what if the data is biased? What if the data is skewed to a certain demographic? So you have to do all those fixes. So when you go and give it to a model, is able to perform correctly and accurately to what the real world is showing. So another neat thing that you can do is simply pass in a number, I think. So if you want 10 rows, and you just say, give me 10 rows with the 10 argument going in. Cool, simple enough, I think. Nice. So let me see. So how about we start with something simple that I think a question that is commonly asked. So let's say we have all these cases, right? We have confirmed, recover, and deaths. What if we want to know how many to date are there for confirmed, recover, and deaths, right? That's a pretty frequent question that you make, and that you see a lot in, say, the New York Times or any analysis website that has ran some numbers for COVID-19 related cases, right? So the way we can do that is we go into our data frame. This case is called cont AGG, say PD, and sorry, G, and we want to create a new column, right? The way we create a new column here is by providing the 2 brackets and the 2 quotations, right? And within those quotations, we're going to specify the name of our new column, right? So we're basically going to be counting the total cases. And this total cases column will be that exact thing. So what we need to do is basically count the numbers for confirmed, recover, and deaths across each column, right? So the way we do that is we do cont AGG, and we need to pass in which columns are we counting for. In this case, we're doing confirmed, recovered, and deaths. And now that we have identified which ones we want to count, we have to tell pandas to count them, right? So the sum function allows us to do that. So the sum function will basically go to the top row and count all the way to the bottom. So you count all the way to the bottom. So you know how many total cases there are for confirm, recover, and that's that. Then if you do to do bear with me. Okay, yeah, sorry. So the last thing that we have to do with the sum function is pass the axis. And what this means is that do you want to count across or from top to bottom, or do you want to count from left to right? So in this case, we want to count from left to right. So basically for a given day, right? How many cases are there? How many total cases are there? So you can see it here. Cool. Right, so if you keep going down, say like for the 100 day, so by April 30th, 2020, there were about 2,147 total cases, or 60 are fatalities, 260 recovered, and 1827 have been confirmed cases. Cool. Okay, so now the next question that we would like to answer is how many of the cases worldwide are US cases? So the way we can do this is by creating a new data frame. In this case, we're going to call it USDF, and we're going to grab our other data frame, count.agg, and we're going to do the following. So if we want to identify which, if we want to identify which cases are coming from the US, we have to group them by country, right? So you can see here we have all these different countries around the world. In this case, Afghanistan. The way we can filter them by country by providing the country column by going into the data frame and then saying, okay, give me the country column, and then equals, we check if that country is equal to the US. And so this will give us all the cases for only the US. As you can see, other country is US. And then what we want to do is count how many cases there are per day. So basically, if there are, so in this data frame, I think there are rows where the date appear in multiple instances. So we want to group them by date. So you can think of this as, let's say you have a pool, and so you want to collect all the observations that contain the same thing. And in this case, the same thing is date. So do that, and then we do the sum operation again. Neat. So this shows all the total cases for the US. per date. Cool. Nice. Okay, just give me a second. Okay, so next, in this section, we're gonna answer another question before we start visualizing this other part. It's gonna be what is the distribution between cases and deaths for the US? So now we have all the information for the US for each confirmed, recover, and deaths. And so we want to put this in a nice graph. Okay, cool. So since we have the US data frame, we can create a new column, and we're going to count the number of daily confirmed per date. So for example, if we have a row of cases, or confirmed cases for the US, we want to count how many are confirmed per day. And so for this, we can just go into the confirmed column, and we want to count subsequently, right? So for example, in here we have one confirmed case for this particular date. So by 224, we want to have 2, right? So, right. Okay, so so we want to sum up this cumulative, or we want to sum up all the confirmed cases, right? And we do this by using the sub function. So give me a second. Right, and we go over the confirmed column one more time, and then we use the shift function to go to the next row every time. So what I'm trying to say is that, so for every date that we have, right, we have a new case. So we want to add up all the previous dates, and at the end, count up all the dates that we have to today, or all the cases that we have to today. Cool. So this creates a new column. Look at it. Yeah, so the first one is 0 because there's nothing in the previous one, and that's what the shift function does. So we did it for daily confirmed, and now we want to do the same thing for daily deaths. So we simply go to the USDF data frame. We create a new column called daily deaths, and we refer to the deaths column and use the sub function. I'll pass in the deaths column, and then we use shift again. So this is going to give us basically a distribution that shows that at X date, you have Y amount of deaths or same thing with confirmed, daily confirmed. So there's a distribution that is going to show that for a particular date, there are Y amount of confirmed cases. Cool, now the cool part comes. So we're going to plot this, right? So first, we can go to, we can start using Matplotlib, right? So first, what you want to do is create a figure, right? The way you do that in Matplotlib is you do plt.figure, and then you provide the size of the figure. In this case, we want to do 20 in width and 8 in height. So right now we have a variable. We access the Matplotlib library, use .figure to create a new figure, and we provide the parameters for the size of the figure, right? And then we have to do this small thing called subplot, add subplot, which you don't have to worry about much of it. It's just a really inconvenience because you can plot just one plot. So don't worry about it. Just put this on because you have to refer to which plot do you want within your subplot. You don't have to worry about that. Just use 1, 1, 1, and with the add subplot function. And then we want a bar graph. In this bar graph, we want to plot 2 different variables. In this case, it's going to be date, which is going to be our x-axis. Then it's going to be daily confirmed as our y-axis. And here we're going to do color. And we're going to provide a label. And this label is going to be used for our legend. We can call it US daily confirmed cases. And then, so right now we have basically one distribution. So you can think of this as like a bar plot with like multiple bars, right? And each bar will be a date, and the height of the bar will be the number of daily confirmed. So we're gonna have multiple of these. We're gonna have 2 different of them. So then we create another one with ax.bar, and then this time we still want our x variable to be date, and then our variable to be our y variable will be daily deaths. Cool. Okay, here the color is going to be red. And our label is going to be daily. And then to set a label to our x-axis, we're going to call this date with the set underscore y label. And then ax.set for our y label. Name that number of affected. Cool. And then we want to set a title with ax.title, not that text. US daily basis. That's what our title is going to be. And then we can specify where our legend is going to be. and we do that by the lock name parameter, and we're going to do upper left. And lastly, we want to show our plot. So that is plt-f. Run that. Oh, sorry. Oh, sorry. I think I missed something. So before I do that, actually, I think what we have to do is USDF set index. So before we do all that, so as you can see right now, the date is our index. So we want to have a 0 index instead. So I think that's what I missed. Yeah, okay, I missed one part. My apologies. To reset that. And if you look at it, yeah, you can see that it has different indexing now. So if we run this, this should work now. Fingers crossed. Okay, this doesn't work. Cool. So it's probably because we do delete confirmed. Sorry for the difficulties. Trying to code this up from scratch. Cool. Yeah. So we can look at this plot, right? So for this plot, right, we're basically counting how many confirmed cases and how many deaths are added up all together. So you can see by September 2021, there has been about 4 million cases and less than 1 million deaths, I think, for the US. Cool. Right, so it's 416. I'm going to pass it to the next presenter for the second time. So I'll stop sharing here. Cool. And so I think the next presenter is Lily or Mahid.
Yeah, I'll go. So hold on, let me share my screen.
Cool.
Can everyone see my screen?
Yeah, we can see it.
All right, so what I'm gonna do is I'm gonna show how to make a line chart as provided by Plotly. And specifically, I'm going to look at China's data and comparing its daily confirmed cases and daily deaths cases. So it's gonna look a little similar to what Frank did. So what I'm gonna do first is I'm going to make a new data frame specifically for China. I'm gonna call it China _ BF. And I'm gonna grab the data from the aggregated countries data frame that we did earlier. And I'm going to just filter it out for the country called China. And I'm going to group it by date because it'll make everything easier for us. And I'm going to call these sum function just so I can have all those rows running. So to see if everything's good, I'm going to call the head function. All right, so right now we have the confirmed recovered deaths and total cases columns, but we are missing the daily confirmed and daily deaths columns. So we'll need to make those ourselves, just like what Frank had done earlier. So I'm going to make those new columns, daily confirmed, by basically calculating them based on what we have already. So I'm going to grab the confirm column that we already have. I'm going to call the sub function and passing in other confirmed row. Okay. I'm using shift. And I'm going to do the same thing, but for daily deaths. So I'm going to replace confirmed with deaths. Again, just going to see if everything is working. Okay, so yeah, we have our two new columns, daily confirmed and daily deaths, and we know these are accurate because let's say for January 23, there were 643 confirmed cases, and if we subtract that from 548, we would get roughly 95 daily confirmed. So everything is good. So the thing I want in my chart is I want to account for the dates in the chart, but right now our data frame isn't accounting for date, and I kind of want date to be its own column. So what I'm going to do is I'm going to call the reset index function so that date has its own column. So right now we have 6 columns, and now it should be 7 because we have included date. Everything looks good so far. And I'm going to be a bit picky, and I'm going to grab only up to a year's worth of data because right now our data frame accounts for data all the way from January 22, and that's not what I want. So since today's September 24, 2020, 2021, I want something just from last year. I don't want January 22. So I'm going to have to drop some rows to only grab up to that much data. So dropping basically deletes all those rows. So I'm going to pass in the indexes that I want to drop. So that'll be rows 0 to roughly 0 to 246. That'll bring me data all the way from September 24, 2020. So let me see. Yeah, so we have changed our data set. It was originally accounting for all the way back in January. Now it accounts for more recent data up to a year's worth. So now that we have this, we can actually make our chart. And so we will do that by first deciding the colors we want. I kind of want, what do I want? I'm gonna add red and green, why not, to our line colors array. And I am going to now actually make the chart with this information. So I'm going to call the figure fig, and I'm going to call Plotly's function dot line. And I'm going to pass in the data frame that we've been working on, China underscore DF. And I'm going to pass in our x-axis to be date. I'm going to pass in our y-axis to be daily deaths. And I'm going to pass in something called color discrete sequence. And so basically, I'm going to put in line colors so that it can actually make our lines red and green, like I said earlier. So just to see how this looks, I'm going to call the show function. And it'll look a little something like this. So it looks okay. Like this is only looking at daily deaths, which is fine. I also want to look at daily confirmed. So there's an issue there. But one way to get around this is to use the add scatter function, which will overlay another line on top of this. So what I'm going to do is, hold on. Big underscore add scatter. I'm going to set the x-axis to the same thing we've been doing, which is dates, the date column. Oops. I'm going to pass in China, yeah, the daily confirmed column. And I'm going to set the mode, meaning like how we want to represent our line. So you can set it as lines or markers. The difference is that lines will give you legit just solid lines. Markers is going to give you just plots. So I'm just going to settle for lines just because. And I'm going to set the name of this line to confirm. And so that'll make a difference. Here, hold on. Swapping it just so we can see. Okay. So this is what we have so far. So if we roll over any value here, it'll tell us the number of confirmed cases. So on December 26, 2020, there were 81 confirmed cases. And we know it was confirmed because there's a legend on the right-hand side now, meaning that the red line is the confirmed cases. But I'm gonna just tweak it a little bit just to include like the confirmed and the deaths cases. So I'm just going to repeat what we've done, adding scatter, but changing it to deaths. All right, so it looks a bit cleaner now. We have confirmed and deaths in the legend now. And what we're missing now is the title and the axes titles. So I'm just gonna polish that up by calling the update layout function. And I'm gonna change the title to be something appropriate. So it'll be China daily COVID deaths versus daily confirmed. Going to set the x-axis title to be date, y-axis title to be number of people affected. And I'm gonna choose the hover mode, meaning like if I were to hover over any point of this, like what data would I want to show? So I'm gonna put X, meaning that if I roll over any X value, it's gonna show me the respective data for that. You can also put Y, but that'll just give you the date. So that's not going to say anything. So I'm just going with X. And I'm going to just see what happens. So yeah, this is what our chart looks like. So if we roll over any date, it'll give us both confirmed and deaths for the given day. And it looks clean like this. So it kind of shows how powerful like line charts are in Plotly, and you can do whatever you want with this data and however you want to analyze the trends. So that's it for line chart. I'm going to pass it over to Ariana to show you how to make an actual map with this data.
All right. Hello, everyone. Let me just share my screen. All right. Can everyone see my screen? All right.
Yep.
So today, what I want to code up is I want to code up a visualization that basically shows us worldwide COVID data. So the output of this map, I should be able to toggle on a specific date within a certain frame and hover over an area on the world, and it should tell me how many new cases were generated for that specific day, or how many new cases were populated. So in order to start doing that, we're going to use two libraries. We're going to use pandas and we're going to use Plotly Express. So I'm going to start by doing import pandas as PD. And then I'm also going to import Plotly Express as PX. Okay, so these are the two libraries that we're going to be using to code up this map. Now, before I run this, I also want to create a new data frame, and I want to import the data that I'm going to be using to populate this map. So I'm going to do that by calling my data frame df, and I'm going to set it equal to pd.read underscore CSV, which is basically reading our data. And I'm going to use a data set with this specific link. So I'm just going to populate the link in here as well as in the chat. So now if I run this, it should run perfectly fine and with my imports of the libraries and with my data set. All right, so now I just want to see what I'm working with. So I want to output the first 5 rows of my data set. So in order to do that, I'm going to say df.head just to see what is in this data set. And I'm going to run this. And here it shows me the first 5 rows of my data set. So we have the ISO code, continent, location, date, total cases, new cases, and all these non-existent values, which we're not going to worry about right now. So what I really want to work with is I want to work with the location, date, and new cases. But first, before I do that, I want to sort the values so that they can be organized by the date. So in order to do that, I'm going to say df equals df dot sort underscore values to sort these values. Then I'm going to say by equals with brackets date, and I'm going to close the parentheses, and I'm going to run this. What? Okay, so it looks like I have an error. Okay, I forgot the S in values. Yes, thank you for that. All right, yes. All right, so now I sorted my values by the date. And now I could view my head if I wanted to, but I just want to get right into plotting my map. So to do that, I'm going to create a figure, and I'm going to create a figure in Plotly's library, and I'm going to create a map specifically called a choropleth map. And what that basically is going to do is it's just going to show us a worldwide visualization of the world, and I should be able to hover over it, a specific location. And on the specific location, it should tell me on the date how many new cases of COVID were populated on that date. So to start us off, I'm going to say fig to create a new figure equal to px dot choropleth, which is right there. Then I'm going to say df because I want to use the data frame over here in our map. So I'm going to say df. Then I'm going to create something called locations, and I'm going to set that equal to something called ISO code. Right, so if we look here, there's a section on our head called ISO code. What an ISO code basically is that countries are identified by their ISO location. So Plotly has the geolocation, and that's how we're able to populate these countries and look them up by their ISO code. All right. So now I'm going to say color equal to new underscore cases, right? And what this basically does is this is the column that we want to plot. So I want to see how many new cases are coming at a specific location. So I want to plot this. Okay. Then I'm going to do something, say hover name equals location. This basically is whenever I hover over my map, I want it to tell me which location that I'm hovering over. Next, I'm going to do something called animation underscore frame, and I'm going to set that equal to date. Now, this is the column that I want to run the animation on. And in this case, this is the date. And then next, I'm going to put the title, and I'm going to call this daily new COVID cases. Now afterwards, I'm going to say color underscore continuous underscore scale. Now what this does is basically this allows Plotly to continuously change the axis and the colors as the slider is moving. So when the graph populates, there's going to be a slider that populates at the bottom. And whenever I move it to a specific date, Plotly is going to change the color based on how many new cases are in that specific location. So here, I'm going to set this equal to px dot colors dot sequential dot curve. Okay. And then after this, I'm going to do something called fig layout dot pop update menus. This will basically create the slider that will toggle our date. Okay, so in order to do that, I'm going to say fig layout dot pop update menus. And now I'm going to show my figure by saying fig dot show. And I'm going to run this and we have another error. I think I spelled continuous wrong. Sorry, I don't know how to spell. There we go. And we're going to wait for it to populate. It's taking a while. Now there's something else wrong. Fig that layout. Hold on.
Sorry, Ariana, is it because the update menus is enclosed in brackets? It should be parentheses.
Oh yes, you're right. Thank you for pointing that out. I'm gonna run this, should run now. So not only can I not spell, but I don't know the difference between brackets and parentheses. Forgive me. All right, it should load now though. Okay, here we go. Now, finally it loaded. All right, so here is our map. So here is the legend. So new cases, depending on which section it is, it's going to be populated through this color scheme. Now let's test it out. So right now, this date goes from January 1st, 2020, and it goes all the way down to present day, which will be September 24th, 2021. So let's say I want to move this scale to just some random date. As you can see, colors are starting to populate. And if I continue to move it around, you can see the different transitioning in colors, which basically saying the new cases that are populating in different areas of the world. So let's say I'm going to set it to February 21st, 2021, and I hover over. So for the United States on this day, the amount of new cases that came about is 57,000. And I can go all around the world. So for Russia, 12,000, for Brazil, 29,000, and etc. And you can also zoom in, pan around, and look at the different places on the world. And if you want to see a specific date, how many new cases were in, China on that specific date, you can just hover over these locations and it'll tell you. So yeah, that is basically my map. And now I will pass it on to Maheen.
Hi guys, let me share my screen.
Give me a second. Yeah, can you guys see my screen? Hello?
Yep.
Yeah, nice. All right, so hi guys. So I will be showing you guys how to create a global map, just like Ariana did, but I will be showing you how I can break them down into the confirmed, recovered, and their total deaths interactively. So I have installed the PyCountry library. I will be using it. And then I have installed all my other, I have imported all my other libraries, and I read my CSV file, and I named it as cases. So moving on, my plan is to basically, so let me show you how the data looks like right now. So it has date, country, the confirmed, recovered, and the death cases. And this is how it looks like. So my plan is to group them by using the countries. And then I'll show you what's the next step. So I'm going, so give me a second, yeah. So I'll use my data frame cases, and I'll use the group by function, and I'll use the country, the column that I want it to group by, and I will aggregate it using the function sum. And I will store it into my data frame cases. So the step is pretty easy and simple. I'm just trying to group by everything using the country column, and I run it. Okay, so then I want to show you how it looks like. So it's pretty simple. It's nothing crazy here. Yeah, that's how it looks like. Now the plan is to, other than the country column, we have the confirmed, recovered, and the death cases. I want to list all of them into a date list column. So afterwards, I will be manipulating that specific column, and I will use that column in my map. So I'm going to use my data frame, and I will want all the columns, and I want to list them up. So I use the function list for it, and I name it as date list, whatever you guys want to do. And I run it. Okay, so now this is done. I want to show you the list of it. So we know that these were the main variables. We will be using them in our map. So date list, let's run it. Yeah. So the next step is just to, so Ariana's data frame basically had the ISO code, and that is a blessing, but mine is a little different than hers. I need to create my own ISO code, and that is why I wanted all of you to download the PyCountry library, because I'm going to match my ISO code with whatever is there, and I'm going to install them. So I want to define a function here. I'll call it get country code, and I'll pass in the name of the country that I want to find. I'm gonna try. I'm gonna pass in a try and accept block here. Why? Because I want to try a piece of code, and I want it to return me whatever is in PyCountry library. Go there and then find me the countries, and then look up for the name that I am searching for, and then give me the alpha 3. Alpha 3 is basically the 3 letters of a country. So for example, if it is United States of America, it's USA. So I wanted to do this for me. And if it doesn't run, then just return me nothing. So let me just make sure that this is indented properly. I don't want it to run into an error. Okay. and let's run it. Okay, so this works. So now I have my function. I'm going to use this function and find my ISO codes. So how I'm going to do it is, give me a second. Okay, so I'm going to use the country that is in my data frame, for example, of Afghanistan or any other country. So basically, I'm going to use the indexes and I'm going to install them with these. So let's use our data frame, and I want it to use a function index. And then I want it to call the country. So use the column country and find the countries. Okay, so let's run it and see if it works. Yep, it works. Now I want to use whatever is stored in this variable country, use that and apply that function that I just made. So I'm gonna use the country column and I'm going to use a function apply. So let me explain you what apply does. So it's just going to go to the function, get the name of the function, then go to the country library, get the name of the specific country, and then it's going to apply the ISO code. So I just apply the function here and I define it as, just name it ISO alpha 3 or 2, whatever you want to do. And it should work. Okay. So now this is done. Here I want to show you guys. So let me show you. Okay, should I just show you my final map so we know what we are planning to do? Okay, let me show you my final map. So, oh wait, give me a second. No, let me just keep. Yeah, let me just keep it a secret for now. Okay, so the plan is to have a yeah, I love secrets too, Lily. So the plan is to use different variables. So the reason why I made the date list is that I want all the variables to store in that date list, because at the end of the day, we are summing up the total cases across the world. So what I'm going to do is I'm going to use a function melt. So melt will help us to basically unpivot the confirmed, recovered, and the death cases and put them all in a long column. So instead of a wide column, we will get all of them in one column. And I want them to tell me the total number of cases. So basically associate them with the variable. So I use the function melt. You can read whatever it does. So I'm using the data frame that I have. Then I'm basically using the ID variable. ID variable means identifier variable. So there are two identifier variables in my case. Number one is the country column. Number second is the ISO code. So I use the country, and I use the ISO alpha 3. Where's my 3? Okay, yeah. And then I want to use the other variables. So the other variables were basically stored in that list here. So I'm going to use this as my variable value and value variables, and I'm going to say date list. Yep. And I'll just call it df long or short because it's going to be in a long way, so I just want to say it long. And I run it. Okay, so let me show you how it looks like. So all the struggle was just for this long column. So go back to what we had before. We had confirmed, recovered, and the death cases in 3 separate columns. Now I have them in one column under the name variable, and have the value of each confirmed cases of each country, and I have the ISO codes as well. So we are good. Let's move on. And now I want to basically use my global map, and I want to use all this function and show you what's the final figure looks like. So I use the function figure, I use the variable figure, and then I use the px, that's the Plotly Express a library, and then I use the Choropleth. It's a difficult name, to be honest, so I don't want to say something weird. Choropleth. So I'm gonna use all the arguments inside it, and let's do it. So the latest was the one that we just made. Now the locations, this is something that Ariana just showed us, so it should be easier to do. Locations, I'm gonna use the ISO alpha 3. Then I'm gonna do the color, populate the map depending on the color, depending on the value. Yeah. Okay, then is the hover name. For me, hover name will be the variables that I just made. So do the variable. Then comes the animation frame. Wait, the hover name is the country, sorry, because I want to go to my map and see the countries and then hover on them. So country and the animation frame is a variable, basically, my bad. Okay, we move forward, and then I want the color continuous scale. So just the scale, I'm gonna show you few colors and we can change them accordingly. So I'll use peach for now. And then I want to use the projection. For now, let's do it orthographic. And last but not the least, it's the range color. I'm done with I literally did this entire thingy 4 or 5 times a day. So now I know what I'm typing. I hope this is correct though. Don't want to jinx it. So my data for some reason had enormous cases. I don't know if it was true or not. So let's see what it looks like. And yeah, the code is right though, guys. I'm telling you, there's nothing wrong with the code. Show. So let's go. Let me just confirm it one more time. So I think it's good to go. Okay, ta-da. Yeah, this is how it looks like. You can go back and forth, change the colors, see the deaths and stuff. It's almost the same like what Ariana did, but hers was independently one day, and mine is basically the confirmed, recovered, and the death cases. And I want to, it's like you can just change the projection to see some different view. I'll do natural earth. I'll do yellow, green, blue. This is something I would love to do. Yeah. Okay, yeah, so this works. So if you have any questions, do let me know. If not, then this was all from my side, and over to you, Frank.